Hello everybody, welcome our second tutorial of PN driver engineering and runtime series. In this video, we will create a PNConfiglib project with PN driver, KP8 and ET200SP. After this video, you will have a better understanding of creating engineering project for PN driver by using PNConfiglib. Let's get started. I downloaded the PNConfiglib from the CEOs before this video record. You can also download it from the link I shared in the description. I created PNConfiglib and PNConfiglib runner executables and as explained in the user manual. Let's start by creating an empty project in the Eclipse and prepare XML files afterwards. Let me give PNCL project as its name. Afterwards, I need to locate the project directory. I'm navigating the PNCL folder and create an empty folder to save this project. By clicking Finish, we are completed. Now we need to create XML files. I'm going to create configuration XML first. An XSD schema file is used in order to make XML input. We can import the XSD file from the PNCL delivery folder. Let's select the configuration XSD. We need to remove the prefix that added automatically by Eclipse. We need to add all of the central and decentral devices we are going to use in this project to the configuration XML. Let's start by adding central device, which is PN driver in this case. A device ref ID needs to be selected. I'm assigning PN driver-1. As interface ref ID, I'm assigning PN driver-1-interface. Let's add our first decentral device, key panel 8. I'm assigning KP-8 as device reference ID and KP-8-interface as an interface ref ID. Let's add our second decentral device, that is ET200SP. I'm going to assign ET200SP-2-interface as interface reference ID. Now we can add Ethernet settings to the project. I'm going to start from the controller. I'm selecting the IP address randomly. We also need to assign a device name to the PN driver. IP address and device names need to be assigned to the decentral devices as we did for PN driver. I'm going to assign a random IP address, but it is very critical to assign an IP address in the same network. As device, we should set 1 for the first device. I'm going to assign KP8 as device name. I'm going to assign Ethernet parameters for ET200SP. Now we need to add modules of ET200SP to the configuration XML. I'm going to add a digital input module to the first slot and a digital output module to the second slot of ET200SP. I have selected a random module ID. Slot number is where I placed the module on ET200SP. GSDRef ID is the reference ID of the module which is located in the GSD file of the device. If GSDRef ID doesn't match with the value in the GSD file, there will be errors in the project. Let's add our second module, which is digital output in our case. The module is plugged to the slot 2, therefore I'm writing slot 2. I'm passing the GSDRef ID that I have copied from the GSD file of the device. We are almost done. As the last step, we need to add send clock value to the project. I'm planning to create a real-time network that has send clock value of 1 millisecond. Therefore, I'm writing 1 to the send clock value. I'm assigning configuration-1 as configuration ID. We are done with the configuration XML. We can now create list of nodes XML input. I'm creating the list of nodes XML as I created the configuration XML file. List of node XML also needs to be created based on XSD schema file. I'm selecting the corresponding XSD file. Prefix also needs to be removed. In the list of node XML, PN driver variants come automatically from XSD file. We need to select the correct variant. I'm going to select Linux native. Device ID and interface ID must be equal with the interface ID that we assigned in the configuration XML. Therefore, I'm going to copy and paste the value here. Device version needs to be assigned. Since there is no difference between 2.3 and 2.2 from the engineering point of view, in controller use case, we select 2.2. Let's add our first decentral device, KP8, and get the device ref ID and interface ref ID from the configuration XML. Local path of GSD file of KP8 needs to be given in the list of nodes XML. I have pasted the local path that I prepared previously. I'm going to copy and paste the GSD reference ID of interface module that I used for KP8. This info is found inside GSD. Let's add our second decentral device, ET200SP. Device ref ID and interface ref ID needs to be same as with the configuration XML. I'm going to paste the GSD ref ID of the interface module from the GSD file of ET200SP. Local path of the ET200SP's GSD file needs to be given. We need to assign a list of nodes ID and give this information to the configuration XML to connect both XML each other. Now we are done with the XML configuration. From this point on, we need to give these XML files as input to PNConfiglib runner and compile the project. I'm going to copy the XML files and paste near the PNConfiglib runner binary. Over a command line terminal, I'm going to run the PNConfiglib runner and give the XMLs as an input. After a while, PNConfiglib will produce the engineering XML for PN driver. That's it. Our project has been compiled successfully. This is the engineering input XML file of the PN driver. I hope this tutorial helps you have a better understanding of PNConfiglib engineering with PN driver. If you have further questions, please don't hesitate to contact us from the email below. Thank you for watching.